Now we're going to move on to the concept of beta, and more specifically the capital asset pricing model, or CAPM. Beta tells us how a specific security is going to move with the market. So beta coefficient is a measure of the extent to which returns on a given stock move with the stock market. It represents the average stock. So just for note, the beta market is 1. And so if the beta is greater than 1, the stock is more volatile than the market. If the beta is less than 1, it's less volatile than the market. So fairly simple concept. The entire market, extremely well diversified, theoretically perfectly diversified, because it includes all investments. We know that's not the case, but because investments such as a lot of real estate and human capital, thankfully, are not traded in the market. So if beta is 0.5, this stock is only half as volatile as the market, or half as risky as the average stock in the market. A beta of 1 has the same risk as the average stock, so the same as the market. Beta of 2 is twice as risky as the average stock. So everything, the beta coefficient is relative to that riskiness of that stock. So the beta of any set of securities is the weighted average of the individual securities betas, and again, this is the weighted average is determined by the value of the security and the total value of securities in that portfolio. So, for example, if we had a security was worth $10,000, and our portfolio was worth $50,000, then that the weight of that beta would be 0.2 or 20%. So portfolio beta is simply the weight of each of the individual securities in that portfolio multiplied by its beta, and we sum those up. It gives us the beta for the portfolio. There are a couple of homework problems where you'll be asked to do this. The risk premium for a stock. The risk premium for a stock is simply the risk premium on the market multiplied by the beta for that specific stock. In this case, it's stock J, so beta J multiplied by the risk premium for the market. It's also beta J multiplied by the return on the market minus the risk-free rate. This we're beginning to get into the components of the capital asset pricing model. So risk premium is the for the market is the market average stock risk premium. Return on the market average stock return, and R sub RF is the risk-free rate of return. In most cases, we use treasury bills for the risk-free rate of return. Required rate of return for a stock is simply the risk-free rate plus the market risk premium. We can break that down. The risk-free rate plus the beta multiplied by the market risk premium. Let's take a step back. This is the risk premium for stock J, which is determined by multiplying by its beta by the market risk premium. And then down here, we have the risk-free rate plus the beta multiplied by the return on the market minus the risk-free rate. This, put RJ down here is the capital asset pricing model. So I usually, for some reason, I was taught I put the beta in front here. It doesn't matter. So capital asset pricing model. Model used to determine the required rate of return. It is the most widely used model in stock evaluation, based on the proposition that any asset's required rate of return should equal the risk-free rate of return plus a risk premium that reflects the asset's market risk. So they are non-diversifiable risk. Also systematic risk. So again, required return. This is also there's a couple. It's also called the hurdle rate, and the one of the ways I like to refer to it as the fair return. So, because a lot of times you'll be discussing expected returns, and the capital asset pricing model will give you an expected return, but it is we need to differentiate. So hurdle rate, so forth. So, but anyway, so we take our required return. It's equal to the risk-free rate of return plus the risk premium that's associated with the market or systematic risk. And that is the beta for that stock multiplied by the return on the market minus the risk-free rate.